Let's continue on with the homework questions from section 6.5, and let's start with question 4C, and I need to write out the first four terms of the recursive sequence here. And we're given that the first term is 2 and the second term is 3. So let's just write that on the side here. The first term is going to be 2 and the second term is going to be 3. So our goal now is I need to find the third term and the fourth term. Okay, so if I want to find the third term, basically you need to change all the n values to 3. So this would be a of 3 equals 2. Now over here, if n is 3, this is really a and then a subscript of 3 minus 1 plus a, and over here I have n minus 2, so the subscript there would be 3 minus 2. And if I want to find my third term now, and if I go ahead and evaluate my subscripts here, this will be a of 2 plus a of 1. So what is my second term here? So my second term has a value of 3. So that's going to be 3 plus, and then what is the value of my first term? Well, the value of my first term is going to be a 2, so 3 plus 2 is going to be 5. So my third term has a value of 5. Okay, and then now we need to find the fourth term. So basically anytime you see these values of 3, we're going to replace those with 4 now. So a of 4, 4, and 4, because I want to find the fourth term. So if I want to find the fourth term here, this is really the third term. 4 minus 1 is going to be 3, and 4 minus 2 is going to be 2. So I need to find my fourth term here, it's really the third term, which has a value of 5, and my second term, which has a value of 3. So 5 plus 3 is going to be 8. So my fourth term has a value of 8. Okay, let's move on to some of the other questions that we have here. So for question 5b, I need to find the sum of each sequence here. Okay, so what we're going to do with this problem here is we start off with k equals to 1. This is where we start, and we end when k goes to 4. Okay, so what we're going to do for this problem here is we're going to change the value k, and our first value k is going to be k equals to 1, so that'll be 1 squared minus 2, and 1 squared minus 2 is the same thing as 1 minus 2, which equals to negative 1. All right, so the first term is going to be negative 1 in our sequence. All right, and then I change my k value here. That k value there is now going to change to k equals to 2 now, so that's going to be 2 squared. So 2 squared is going to be 4, and 4 minus 2 has a value of 2. So the second term is going to be positive 2. Okay, and then my third term is going to be now, so I'm trying to erase all that. So now k will now be 3 here, so I can change this now to a 3. So 3 squared is going to be 9, and 9 minus 2 is going to be 7. So 9 minus 2 is going to be 7, so my third term is going to be positive 7. And if I want to find my fourth term here, I change this value here to a 4. So 4 squared minus 2, well, that's going to be 16 minus 2, and 16 minus 2 is going to be 14, so plus 14. All right, so if I want to find the sum, I just add up all these numbers here. And if I add up all those numbers very carefully, you should get a value of 22. All right, so that's how you do one of these sum questions when you're given the sigma notation. And let's do one more here for practice as well. Find the sum of each sequence here. All right, so so one thing I noticed right now is k equals to 1. So this is where you're going to start, and this is where you're going to end when we get to the fourth term there. So anytime you see a k value here, the k value there will change to 1, then 2, then 3, then 4. All right, so if k equals to 1, that's the same thing as like 1 squared divided by 2, and 1 squared will be 1, and the bottom will be 2, so the first term here is going to be 1/2. Okay, and then I just change this value right here, this 1 into a 2. So that's going to be 2, so 2 squared. So 2 squared has a value of 4, right? And 4 divided by 2 is going to be positive 2. So my second term is going to be positive 2. And then now let's find my third term here, so I'll change that to a 3. So 3 squared is going to be 9. And 9 divided by 2 is roughly, I don't know, that's about 4.5, right? So half of 9 is 4.5. So my third term is going to be 4.5. And then let's change my 3 to a 4 now, to my fourth term. So 4 squared is going to be 16, and 16 divided by 2 is going to be 8, so plus 8. Okay, and if I add up all this together here, if I add up those 4 numbers there, I should get a value of 15. So that's my answer for question 5E. All right, let's move on to question 6A. So I need to express each sum using sigma notation. So, sorry, summation notation. So if I'm using the summation notation, we need to use the sigma symbol here. And I need to start with an index of k equals to 1, which is fine. That means the bottom number here is going to be k equals to 1. And if I count up all these the terms here, I have 1, 2, 3, 4. So there's 4 terms. So my top value here will be 4. Okay, so we've seen some of these kind of problems. We've got to figure out how to write the formula for this pattern here. And basically, if I'm going from 1 to 3, I need to add 2. And if I go from 3 to 5, I'm also adding 2. If I'm going from 5 to 7, I need to add 2. So we've seen some of these kind of problems before in previous chapters, especially in the graphing chapter here. So since we're increasing by 2 each time, that means 2 needs to be in the formula. Right, 2 has to be in the formula. Okay, and what I like to do next is, I know you can pick any number here. Let's just pick this number here. I know this is the 4th term, right? This is the 4th term, right? So what I like to do is, I like to do this. I like to times 2 by the 4th term. So 2 times 4 is going to be 8, right? And what do I have to do to 8 to get to a 7? Well, I need to minus 1, right? So it's 2 times the term number and then minus 1, and that will give you the term value for any term in the sequence here. So let's try that with the second term here as well, right? This is the second term, right? So that means n equals to 2, right? So if I plug in 2 here, 2 times 2 is going to be 4, and 4 minus 1 gives me 3, which matches the second term there, right? So there it is. There's my formula. It's 2n minus 1. All right, so since I'm dealing with the variable k here, I just changed this value of n to k, so this will be 2k and then minus 1. All right, so there you go. There is my answer for that particular problem. This is the sum using summation notation for that problem. Okay, so move on to the next one here. All right, so once again, I need to use summation notation. So I need to use the sigma symbol here. And I know that the index starts with k equals to 1, so k would equal to 1. And now I have 1, 2, 3, 4, 5 terms, so I need a 5 at the top here. And this one isn't too bad because here's a 1, here's a 2, here's a 3, here's a 4, here's a 5. So basically we're going up by 1 each time, and we're going in order. So in order to represent that, that's just simply going to be the variable n, right? Or sorry, not the variable n, I'll use k, because we're using the k for the variable here, right? And since we have powers of 2 since we have 2 for the powers here, we can just modify this by putting a 2 there, and that should do it. One thing that you should always do is you should always just check your work too. So if I know that k starts with 1, that means if I expanded this would be 1 squared. And the second term would be, this would now change to a value of 2. So 2 squared would be just, 2 squared, which is 4. And then it would be 3 squared, then 4 squared, and then I stop at 5. So the last term will be 5 squared. And you can see this this expanded sequence there does match the problem there. So you could feel pretty confident that your formula here of this sum right here is actually correct here. So you can always check your answer by just plugging in the values of k. Okay, let's try one more here. These ones aren't, these are the ones I think students will probably find the easiest, because you can start off by using your sigma notation with k equals to 1. And one thing that you might notice is that there's this plus dot 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 dot, so that means the sequence goes on forever. If the sequence goes on forever, so what that means is you can put an n here at the very top. That just means this sequence goes on forever. And all you're really doing is you're just you're basically copying this last term here. So instead of using n, you would just use k. So k over k plus 1. And there's your formula there. And if you want, you can go ahead and just test this out here. So if you let k be 1, your first term is going to be 1 divided by 1 plus 1, which is really 1/2. And that really matches that term right there, right? And then the second term, what would happen there is k would now be 2. So this would be 2 over 2 plus 1, which is going to be 2 over 3. And clearly we do have 2/3 for our second term there, so that is matching up correctly there. So I find that these kind of problems where they kind of give you this last term here, it actually makes the sigma notation question actually quite easy, because they actually just kind of give you the answer, and you just need to kind of fill in the missing variables there. Okay, so once again, just to kind of wrap up another one of these summation notation questions here, let's do this one very quickly now. So I know that k equals to 1, so k equals to 1. I see a plus dot 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 dot, so that's going to be a infinite sequence here. So this stops at the last term, which is n there, and we just need to kind of copy this out. So that's going to be 5 to the power of k over k. And that should do it for that particular problem. Okay, let's move on to question number 7 here. Write the first 5 terms of each arithmetic sequence here. Okay, so over here I'm going up by what, plus 4, plus 4. All right, so keep on adding 4, so I get 19 and 23. This means my first term is a 4, and my common difference is a 2, so I just add 2 each time. So 4 plus 2 is going to be 6. So my second term is 6. My third term is going to be 8. My fourth term is going to be 10, and my fifth term is going to be 12. So 4, 6, 8, 10, and 12 for that particular problem. Okay, and one last one here. My first term is going to be -5, and my common difference is -3 over 4. Okay, so my first term is -5. And before I do this particular problem here, I'm just going to change this to a decimal number. So this would be -0.75. You don't have to do this, but if you write it as -0.75, you can kind of crunch the numbers in your head here. So the second number is going to be -5.75. We're pretty much subtracting 75 cents each time. And then I have -6.5. And then I have -7.25. And then if I subtract another 75 cents, I get -8. So those are the first 5 numbers in that particular sequence. Okay, so move on to question number 8 now. So find the indicated arithmetic term. So for question 8a, I need to find the 12th term there. So all you're doing is you're using the formula, which is t of n equals to the first term plus n minus 1 times the common difference. Okay, so our goal now is I want to find the 12th term, right? Okay, so first things first, anytime you see the variable n, that changes to a 12, right? And what is my first term? Well, my first term is a 5 plus 12 minus 1, close the bracket, and what's my common difference here? Well, my common difference is 3, so let's put a 3 there. And after that, you're just doing some arithmetic here, some calculations. So 12 minus 1 is going to be 11. So finally, we have 5 plus 33, and 5 plus 33 is going to be 38. So the 12th term is going to be 38. Okay, for question 8b, I need to find the 9th term. All right, so let's start off by writing our formula here. So this question isn't too bad. You're just kind of plugging numbers into the formula here and just practicing your calculation skills here. So I need to find the 9th term. So anytime you see the value of n, that changes to 9. What is my first term? Well, my first term is 2/3 plus the value of n is 9. So 9 minus 1 times the common difference. And the common difference here is going to be -1 over 4. Okay, so a little bit of fraction work to do for this particular problem. So this will be 2 over 3 plus 9 minus 1 is going to be 8. And I times this by -1 over 4. Okay, so I have 2/3. Okay, so 8 divided by 4 is going to be 2, right? But since there's a negative and a positive sign, that's going to be negative. So 8 divided by 4 is going to be 2. So it would be 2/3 minus 2. And this is where we have to do a little bit of fraction work here. So 2/3 minus, now you need a common denominator here, so times the top and bottom by 3. So I get 6 over 3, And if I just do 2 minus 6, 2 minus 6 is going to be negative 4 divided by 3. And there's your answer for question 8b. Okay, let's move on to question 8e here. 8e. So I got to find the 40th term here. So once again, let's start off by writing out the formula here. So t of n equals to a plus n minus 1 times d. And I want to find the 40th term. So my value of n is going to be 40 here. So my first term is going to be negative 0.75 plus 40 minus 1 times the common difference, which is going to be 0.05. Okay, so now I have negative 0.75 plus 40 minus 1 is going to be 39, and 39 times 0.05. Now from here, I recommend you just go to a calculator and just figure out the numbers here. That's going to be negative 0.75, and 39 times 0.05 is going to be positive 1.95. And if I subtract 0.75 from that, I get 1.2. All right, so that's it for this homework video guide, and we'll do part 3 next time.